Okay, so this work may be a little bit different that we have seen so far on this symposium. So it's like related to documents. Okay. So annotation of strict out text in handwritten documents. So we are all working in annotating. Okay. So what is handwritten text recognition? First of all, so there's automatic transcriptions of handwritten text into computer readable text. So for example, this is one of the handwritten document, which has been widely used for a recognition purpose. The English handwritten recognition purpose is called from the IM dataset. So this is the transcription, the computer readable transcription, the wanted. Okay, the handwritten text recognitions are like, there's a lot of applications for handwritten document retrieval, answering some questions, and signature verification, etc. And so this problem is still considered as unsolved problem, although the people are working in this area from decades, but it's still unsolved because of the variety in handwriting styles and the cursiveness in nature of handwritten styles, right? So although some of the recognizers, recognizer which convert handwritten document into computer readable text, okay? So these recognizers are producing reasonably good results. So it's almost 95 to 96% accuracy they are giving. But these recognizer expect that the handwritten document should be in a specific format. So the example we have seen previously, so this one is from the IM database, so we can see it's clean and the lines are apart from one another, right? So there is, so this is, a clean and organized document. But if you talk about a real handwritten document, so this is one of the example I haven't used in this paper, but these are the example of a student's handwritten samples. So this is a student paper, so we can see like there are some crossouts, right? So there are some underlines. And this is in another example where they start to rewrite some text, they cross some text and they rewrite some text. There are some errors, right? So there are some other stuff also involved in real handwritten document. It's not always clean and in a restrict manner. So if okay, specifically, I'm talking about handwritten students' handwritten samples because I'm working in that area, like dealing with the students' handwritten samples. So if you feed a handwritten sample of a student, like for example, this sort of paper, into the recognizers that are giving 95 and 96% accuracy, so we are expecting it will probably give us unsatisfactory results. So because there are some elements which are unknown to the recognizers, and these could be the background prints, crossouts, or some physical damage during scanning process. So practically, when we see these sort of elements, so we ignore while reading because it's hold no information for the readers. So we have to represent all these different elements in a way that the recognizer can differentiate between a regular text and a non-regular. So from these elements, we picked the crossout text because these things are commonly we can see in handwritten documents. So crossout comes in different lengths and shape. Length means one word can be crossed out, or two words or even a part of word can be crossed. And shape means what kind of stroke is used to cross out the text, you know. So it's a single line, a double line, or diagonal line, or you can't even name that, you know. So in this figure, we can see that the when is crossed using a single line stroke. This no is crossed with double line stroke. Version is diagonal, and this the but is with the two diagonal strokes, right? The primary goal of this work that we want to investigate that the differences between using annotated and non-annotated training data in terms of model development and test recognition accuracy. So for this purpose, we will be using, we have used IM dataset. So IM dataset consists of three predefined sets. One is training for validation and testing. So all the people who involved in handwritten recognition task, they are using this predefined sets. And there are 79 different classes. So it includes alphabet, numbers, and some special characters. So the IM database, as I already said, that it's like free from any editing operation, because the generation process or the production process of IM was involved to copy a text which is already written in front of like the volunteers. So it's organized and it's clean. So for that purpose, like we don't have, there is no data set available which contains like Crossout Text for handwritten recognition purpose. So what we did, we generate a synthetic one. For that purpose, we took handwritten lines, like 20% handwritten lines from IM dataset. So I will show you one of the example, like how we did it. So we considered three type of three properties. One is stroke style, stroke color, and stroke width. So stroke is which is used to cross the the word. So this is one of the image. First, using connected component, we detect the bounding box around each word in a handwritten line. So then we randomly select one of the word, and we also randomly select one of the stroke style, and then using histogram-based method, we detect the color, right? The color in the image, a pixel value, and we also detect the width using the active distance transform method. So this is how we generate like the stroke. So it's a double line stroke. Now the after generating a stroke, like superimposing a strokes on a word, now we have two choices for labeling it. One is with giving a representation of this cross-out word, right, with the symbol hash. So we use symbol hash because this symbol is not used in IM database for any other purpose. So and the other one is without giving any representation. So the label 2 is actually reduce the burden of annotating any non-regular text. So so for that purpose, we want to investigate the label 1 and label 2 approach, like which approach is better in terms of when there are more struck out in a handwritten document. So how will recognizers will react to that? So we have already the IM dataset. Now we generated two versions of that. One is extended IAM with hash, in which all the struck out text it's represented with symbol hash, and the other one extended IAM without hash. So in this version, we ignore the representation of struck out. So we didn't give any sort of representation. So we can see in this example, like they will probably give us their hyponetic. So the ground truth say, okay, so here is with the probably, which has been crossed. So we give the representation, and here we are not giving any sort of representation that. So these are the number of lines of where a struck out word is present, is there, and the non-struck out mean there are lines which there is no cross out. So we will be testing this, our model on 495 images. So this is the simplest model we have used for our purpose. We train this model 3 times, one on IAM, one on extended IAM, and one on without extended IAM. So there are like 5 convolutional network, and then it's followed by the 5 layers of bidirectional LSTM, and it's trained with CTC with using CTC loss and atom optimizer. The results says that, okay, so we have 3 models, and we have 3 test sets, right? One is IAM, there is no cross out. So we got 7.1 character rate, and word error rate is 22%. When we introduce, if we see here, when we introduce cross out, when the model is not trained on cross out, so the character error rate is increased from 7 to 11. Same here from 7 to 11, right? So it means when we introduce a cross out, right, when we want to test a new, when we want to test something which contains cross out and it's not trained, it means it like the chances of character it will increase. Right? Model with hash, so it's trained or model, it's trained with IAM, which contains hashes, right? So we got 8.3% character error rate on IAM test sets, and 8.8 character error rate on extended IAM without hash. Model with hash, so we can see, okay, so the results are like so many results. So I will conclude that. So we can see the difference with these 2 models, right? So because we investigated these 2 models, it's 8.3 and 8.5. The difference is not that huge. Same is here, it's 8.8 and 9.0. The difference is not that huge. But to check that the different is statistically significant or not, like so we perform a statistical test. So there were total 1840 handwritten images involved in test set. So we do, and these images are written by 128 authors. So so we divided according to the authors. So and then we apply statistical tests. We got the p-value is around 0.26. So which shows that the difference is not statistically significant. So it means that there is no difference if you give a representation to struck out or you just leave it without any representation. But there is some more insight of the cross-out regarding cross-out text detection, right? So the model which was trained on with hashes, right? there were 495 crossouts. So 440 crossouts was detected correctly. There were 55 false negatives, and usually they consist of like a short words, for instance, the, it. So we can see some of the examples, like for example, this A has been crossed and it's not detected as cross, and they say, okay, the predicted is A. Same as any, which is like the shape of this word is not like somehow destroyed, so they detect it as it's not crossed. Same is the case with false negative. So we detected some of the false negatives as well, where there is, a streak stroke involves, for example, it or the, and there are some also short words in which the model detected as crossout, but actually it was not. Right? In a conclusion, there is no difference if this we have concluded that there is no difference if the strike through text is annotated or not. However, like if you are providing a representation for cross-out annotations, so it will help to assess the performance of the model for cross-out detection. And it's the cross-out detection, like recently the researchers are doing work on cross-out detection task because it's useful for writer identification and also for personality test. So for writer identification task, they just want to remove the stroke, and like, so if you are planning to work with cross-out detection, that what has been crossed or why this has been crossed, right? So annotating cross-out is a better option. But on the other hand, if it's not giving any annotation, it will reduce, the burden of labeling data. So there are limitations in our work as well. So we consider very small number of styles, stroke style. We consider only 4, which is like single line, double line, diagonal, and the cross stroke. And all the strokes are synthetically generated, and it also contains only one word. So it's not always true, like some in some cases it's 2 words, and somehow it's a part of word which has been crossed. So these are the limitations of the work, and thank you.